Okay, so hi, welcome back from lunch. My name is Rudolf Fleming. I work for a company called SensePost. We do assessment services, penetration testing. We're based in South Africa. Very small company, only 11 people working for us. My financial director said I must... Okay, is this better? So I have to speak like this all the time? Okay, not a problem. Okay, should I repeat that? No? All right, that's cool. Let's go on. Okay, so what we're talking today is CyberTerrorism. Putting the T back into CyberTerrorism was quite funny. When we first submitted this talk to Black Hat, they said that we misspelled T. Now, it's intentionally spelled T-E-A, and you'll see why just now. Okay, so that's the background. We're trying to keep our backgrounds as psychedelic as possible. Okay, so let's start off. Cyberterrorism, cyber warfare, is it really such a big deal? You know, people tell me a packet can't fly a plane. Okay, so could we really do something that would really be classified as cyberterrorism? Now, I don't want to go into the details of what I'm about to present, if that is really cyberterrorism or not. I would rather just say, have a look and see and decide for yourself what we can do with this. Thus far, on the internet, when you go and Google for cyberterrorism, you see a whole lot of people talking about it, and you see a whole lot of people saying that it's really not such a big deal, and that cyberterrorism doesn't exist at all. And the reasons for that is quite clear. When you read about cyberterrorism, there's basically two kinds of attacks that you see a lot. The first kind of attack that is documented and that you can read about anywhere is denial of service attacks, right? So there's a lot of people putting out some papers and putting out some documents that says we can build a denial of service, distributed denial of service network, and we can perform denial of service on a whole lot of different companies. And some of those might be key industries and take them off the internet. And so the other side of the coin says, well, you know, if you take them off the internet, so what? You know, they're not connected to the net, but the fact that they're not connected to the internet doesn't mean that they can't conduct business anymore. A lot of the networks are actually air-gapped, or can easily be air-gapped between the internet and these defense networks, those kind of networks. So really, denial of service is not an option for us at this stage. It's annoying, as you might well know, but it's really not going to affect a whole country as a whole if you start doing a denial of service attack. The second group of people talk about cyberterrorism, and they say that we can hack into a, let's say, power grid, and we can shut down the power for a city. Okay, that's a little bit harsh. First of all, people that attempted that kind of thing would know that it is not that easy to do. Okay, you don't just, like in the movies, hack into the power grid and switch it off. It only happens in movies like Matrix. Okay, the thing there to remember is this: even if you can break into a network that is controlling something critical, there's a whole lot of redundancy in systems nowadays. Okay, so first of all, the question is, can you break into the network? Let's say you can break into the network. If you do break into the network, can you get to the sensitive side, which is, you know, controlling the power, controlling telecommunications, that kind of thing? Which I doubt. And then thirdly, if you manage to shut down some critical infrastructure, you will still find that there's so many other providers, there's so many other telecom providers, energy providers, there's so many other redundant systems that you will really need a group of, let's say, you know, 200, 300, maybe 1,000 people to break into these systems at the same time, and at the same time start shutting them down. So what we're finding with these two types of attacks, it's really that they are not that effective. Okay, you won't be able to create the kind of terror that you would want to see. That's the first part. The second part is that if you do a denial of service attack, you will find that a whole lot of companies and industries and sectors simply go on with their lives. The internal network keeps on churning data and information. Their factories still produce cars. You still get your visa and your passport issued. It's not such a big deal. So if we think about cyber terrorism, if we think about cyber warfare, is there something that we can do that can actually bypass these kind of problems? Okay, so what we really need, is, maybe I can just go one slide back. One of the other ways of looking at something like this is to look at viruses or worms or that kind of thing. But the problem with the virus and a worm is that, you know, those kind of biological agents, they just attack anything in their path. They're not really specific. So what we're looking for is something that is really targeted. Okay, it's really targeted at a specific industry or a specific sector in a specific country. And it's very closely focused on taking out exactly that particular company. Be that a company, be that a government department, that kind of thing. Okay? We need it to be closely coordinated. So the idea is that when we do something, we have to do it exactly at the same time. So we would want, let's say we can break into a network or we can cause some problems on a network. You need to do that very closely coordinated. And you need it wide enough in so many different sectors, in so many different industries, that it really makes a kind of an impact on the country itself. You need it also to be very effective. It doesn't help if, you know, two machines, one is the secretary and the other one is the typist, their machine goes down. It's not going to cripple the country, right? So you need it to be really effective. You need it to be widespread. And the other thing that is very important to mention here is it needs to be very fast. Okay? If you do a kind of attack, I always take the example. If you want to, let's say, blow up a building, and you want to destroy that building, you can't take one brick at a day and move it out the building, right? And after a couple of weeks, people are going to start noticing this. The same thing with these kind of attacks. We want them to be really fast. We want them to be effective, focused, and really fast. We want them to be so fast that human intervention is not possible. And to be able to do that, we need to make it automated. Okay? We can't have hackers sitting there trying, you know, let's say you even round up 1,000 hackers and you put them to attack several kind of sectors or industries within a different country. You would still have a problem because it's going to take them, let's say a day or 2 days to actually do something. And that is too slow. So we want something that is automated and basically has a mind of its own. Okay, so let me begin with part one. What we're seeing in part one is a very nasty worm. Okay? We've all seen the effects of what the worms can do out there, but let's look at something that's a little bit different. We know that internal networks are pretty weak, right? I don't think there's anyone here in this class that would vouch that their network, and let's say that network is more than 200, 300 different machines, that there's no vulnerabilities on any of the machines internal to their network. We know that the internal networks are weak. We also know that the perimeters are actually very strong. Well, it's supposed to be strong, right? So how does this happen? Internal networks are very weak because machines that are in the internal network are seldomly patched. Right? System administrators say, here's a new exploit for, let's say, what's the newest one? What's this RPC Windows one? You think they're going to patch all their machines on the internal network? Let's say you've got 10,000 boxes out there. They're going to patch all of that? Maybe they would. But chances are they're going to say, well, you know, and I can hear it on the telephone saying, we don't have any net bias ports facing out to the internet, so we're safe. And it's probably true for attacks that originate from the internet. The other thing is, if you look in a large company, what happens is they say, well, let's deploy a new trading room, for instance, in a bank. And they would put up, 200, 300 new machines in a bank. That's not patched at all. The other thing that is interesting about internal networks, and you would know this if you run a network, is that these networks on the internal side are very rarely segmented on a network level. Okay, so it's one nice flat network that sits out there. You can connect to any port on any machine. There might be a few machines that are firewalled off into different segments, but if you think of it in the whole, the internal network is really a flat network. So these are the problems that we see. The other thing is, a whole lot of people spend, the kind of industry, the security industry is very kind of obsessed with breaking into networks of the internet. So if you find a mistake in a service that's not likely to be internet facing, system administrators just don't spend so much time on those kind of problems. And the kind of security technology that we're seeing is, IDS, firewalls, a whole lot of this stuff is really geared towards protecting the perimeter. So if we were to write a kind of a worm that, let's say, had a couple of different payloads and a couple of different exploits in there to propagate, we could build something that would kind of not work on the internet. Well, we hope it won't work on the internet. It would probably infect a few machines, but really won't be able to cause a whole lot of damage on the internet. However, if you were to launch such a worm or a virus on the internal network, it could become very interesting. So let's have a look and see what we have today to be able to break into machines. Most of these different problems would provide you with remote execution on a machine. Okay, so at the top I have a few problems that my English is not that good. Okay, a few of the problems that have resulted in worms. We think about the IIS Unicode double decode problem, which resulted in NIMDA. The SQL resolution service, everyone remembers Slammer. IDA, IDQ, the OpenSSL problems that we had, even something like Microsoft SQL with a blank SA password. We've all seen these before, and they all resulted in pretty nasty worms that we've seen in the last couple of years. However, there's a few other problems that we haven't seen as worms. Well, not that I could find this morning on Google quickly. Maybe you know of some of these that I don't know about. The MDAC problem, the .printer extension, WebDAV, the new RPC problem that we've seen, and then simple kind of things that are not really a problem in the software, but it's really just a problem in the configuration. If you go to a large company these days, and we've done that, we do a whole lot of internal assessments as well, you would find there's a couple of machines that are running with blank administrator password with $C shared on the local machine. I'm seeing some nods. You know what I'm talking about. Now, if I have a blank administrator password, I can also get remote command execution going by something like PSExec, PSTools, that kind of thing. We also saw the Apache chunk encoding problem. So there's a whole lot of problems out there today that we know about, and that the internet is fairly kind of secure against. But on the internal network, these kind of problems could cause really, or these kind of problems you see a lot on internal networks as well. Okay, so if we were to build a virus or a worm that we're using these particular problems, and we build something that has a multiple payload that can do all of these exploitations, and we release it into an internal network, then I think the chances are quite high that it will cause some kind of impact. I don't know if you agree with me. Okay, so if we build a worm like that, we need to look at a way for that worm to propagate, right? If you look at all the different worms that we had out there in the past, they had some kind of algorithm for finding more food, for finding other machines to infect. And the propagation rate of a worm is kind of closely related to the ability to find new targets and to infect new targets. Now, if we're running on an internal network, the targeting is quite different, what you have on internal networks to what you have on external networks, right? There's some tools and stuff available on internal networks that makes mapping that internal network much easier than mapping the internet. So the first thing we can do when we land on a machine is we extract the IP number and we extract the mask, right? Typically, if you're sitting on let's say a 10-net somewhere, that might be all we need, because we're getting the IP 10, 15, 17, 4, and the net mask of 255,000. And right there, right now, we've got 256 times 255 times 255 times 255 different machines that we can probe, and we know exactly where they are sitting. So that's a good first start. Something else that we can consider, and we've played with this and it works quite well, is looking for SNMP capable devices. So let's assume you're sitting on a subnetted class C. There's 16 IPs there. The first IP there is a router, and we start looking at start bruiting the SNMP community string on that router. We might find very quickly that that router contains all the information to all the routes of all the other networks. If we can't find that, we can do other kind of tricks. Now, in terms of efficiency and effectiveness, it really goes downhill from here. One way of possibly doing it is doing a trace route to the internet and looking at the different networks that we find along the way. Hopefully, if we can execute this thing deep within a network, there's going to be a couple of networks before it hits the boundary router and it goes out to the net. And those networks we can now identify. The other thing we can do as well is we can start doing ping sweeps on networks, let's say one class C above and one class C below our current IP address, and see if we can find something on those networks. We can determine if those networks are local by looking at the response time, for instance, and see if it's on a kind of Ethernet device. And then if we really don't get any of this right, we can even go and brute force some ping sweeps. So we're doing a whole lot of ping sweeps, simply adding a number every time, seeing if we can find any machines that's local to the network there. We found that if you incorporate all of these different methods, your chances of mapping an internal network is quite large. You're probably going to map that network real soon. What's the problem with this? In the previous slide, we said that we want our attacks to be very targeted, right? So the problem is that this thing, let's say we run this thing on an internal network, that there's quite a large chance that we're going to find an IP address that's sitting on the internet. And this will mean that our worm is now going to go out to the internet, which we don't want it to do. We want it to stay locally within that one network. Now, the thinking there is that since this worm is really using what is known as the low-hanging fruit kind of vulnerabilities, it won't be able to propagate through the internet as quickly as it would propagate through an internal network. And the idea is that it would die a few hops away from the boundary router. Let's go on. Let's look at another component. Now, when you think of denial of service, and you think of denial of service on the internet, then there's actually not that much that you can do, right? You can do maybe DDoS attacks and flood attacks, flooding attacks, look for some problems on one packet kind of denial of service attacks. But really, on the internet, you are quite limited in what you do with your denial of service attacks. However, when you are in an internal network, if you are located on an internal network, denial of service becomes very interesting. There's a whole lot of new classes of denial of service that you can perform on an internal network. First of all, if you only stick to flooding, let's say UDP flooding, SYN flooding, that kind of thing, that's quite devastating on an internal network because things happen at wire speeds. So it could be your Giga Ethernet kind of switch, and we can send those packets out as fast as the wire goes. Now, all of you had seen that with something like, what was it, Slammer? It brought down a whole lot of different networks. Not because it was intentionally doing a denial of service attack, but simply because it was sending out UDP packets at such a tremendous pace that the routers couldn't handle it. So if we start doing something that is really crafted towards doing flooding on internal networks, we could probably get even better results. One of the other things that we can do is we can look for ICMP route redirection. Okay, we can start sending out a whole lot of ICMP redirection packets, and that would probably result in a whole lot of Windows machines losing their default routes, losing all the kind of route that they have in the routing table. We can play with, and this we can't do, and this we probably can't do on the internet because that kind of protocol is blocked, right? Because now we're sitting on a flat network. Everything is allowed in and out, so we can play with this stuff. We can also look at something like that, like ARP table trickery. Anyone that's played here with something like EtherCap, was it? It was EtherCap, no? That does the ARP, yeah. EtherCap would know that if you mess around with it a little bit too much, at the end of the day you're burning your fingers because there's problems in the ARP caches happening. So because, again, we're sitting on a local network, we can advertise ourselves as just about any IP address that we want with any MAC. And that starts to become interesting as well. One of the other attacks that we've seen, am I speaking too loud or too soft? Okay. Okay, now I don't know if it's me or if it's him. Okay, so the other thing we can play with, and we've seen that in the past at some of these conferences, is DHCP lease exhaustion. I don't know if you know exactly how that works. It's an interesting attack whereby we can basically change any of the leases that are obtained. Now this is seriously loud now. I feel like I'm in a stadium or something. We can play with DHCP lease exhaustion. We can do something like hijacking of TCP connections if we were able to actually sniff that traffic. There's a couple of things that we can do on the internal network that are quite devastating and that you can't find on the internet, right? And since we are on a machine that's located on the internal network, we can start doing something like, changing doc files, changing XLS files, corrupting zip files, corrupting MDB files. We can do other interesting things. We can try to flash the BIOS of the machine and see if we can maybe take the machine down so that it can't reboot again. We can even do the following, and this is an interesting point. We can have a whole lot of pop-up messages coming up on the machine that would say, your machine has been taken over by XYZ worm, and in order to fix the machine, please read the following 128 characters to your help desk assistant. Now, that's an interesting attack because it would result in the telephone system of the help desk simply, going down the tubes. And it will also keep the sysadmins busy for quite a while. The other thing that we can do is we can start looking at routers that are sitting on the internal network. A whole of these routers are running with, let's say, default passwords. I know Cisco doesn't have any default password, but we can start guessing. Okay, we can say Cisco admin, the company name, whatever, that kind of thing. And once we get access to that router, we can basically log into the router and disable the router. So what will happen is that you will have little clusters of islands that can't communicate to themselves. It will also mean that your system administrator won't be able to get to the machines that are located on any of these islands. So, and I'm sure there's a couple of other things that we can do as well. that can really become seriously nasty on internal networks once we start doing denial of service. This is a kind of, I don't know if you can see that. This is a kind of a diagram of how a basic design of how such a worm would work. On the left-hand side, you have your reconnaissance unit. Is it? That's your left as well? No. Okay. You have a kind of a reconnaissance unit that will use SNMP, the IP mask trace route, that kind of thing. It then feeds into the infection unit, any of the IPs that it saw during the process. There's some kind of a machine between the infection unit and the DOS unit, which we'll get to just now. And then in the DOS unit, we have several different plugins that will simply take out the network. I just want to go one back. There's one problem with this kind of attack, and that is that denial of service and a kind of a biological agent doesn't mix that well, right? So it's no use when you're trying to propagate one instance of this virus, and this instance of this virus is trying to propagate through the network, while the other instance that's living right next to it is trying to kill the network off, correct? Because then it's going to kill itself before it can really spread on the network. So if you look in the paper, you will see that we've worked on a kind of an algorithm to make sure that all the hosts that are potential targets are infected before denial of service occurs. And it's not that difficult to figure out how to do this. Since on the internal network you have a flat network, you can communicate with whatever protocol you want between different instances of this virus. And there's an easy kind of algorithm that says you define a neighbor as someone who you infected or someone that infected you, and then simply after that saying that if you hear about an infection, you tell all your neighbors, or if you infect someone else, you tell all your neighbors. What that will result in is that in a large network, after a while, the machines will know about all the infections that happen on that network. Why is that interesting? We then know that we want to go into denial of service attack mode once all the targets has been infected. So if we don't hear about any infections for, let's say, 10 minutes, we assume that all the machines that could be infected has been infected, and then we go into denial of service attack mode. So the question on everyone's mind is, I'm talking about these worms and these viruses and this kind of thing, and I'm sure everyone can understand that something like this would be kind of devastating on an internal network. The question, however, is how do you get it on the internal network? Well, actually, it is not that difficult to get it running on an internal network. What you can do is you can simply mail it to people working at the company that you're targeting. And now here you're all saying, yeah, but you've got all these content level filters in there that will keep these EXEs and stuff coming in. That might be true. So what you want to do is you don't want to mail the actual executable to the person. You want to mail in a link to the executable. And that particular executable you can then place on a SSL-enabled server. So because you're putting it on an SSL-enabled server, you will find that all of your content level stuff can't read it because it's encrypted. Okay, we found this out when we wanted to send an executable to someone working in a bank, and we couldn't mail it to them because it was being blocked by the content level stuff. We couldn't let them download it either. We couldn't let them FTP it. So at the end of the day, we had to put it on a secure site, on an SSL site, and let them download it from that site. Now, because it's encrypted, all of the other stuff goes away. If we're doing our targeting properly, we can have the company name that we're attacking, right? We can know what the company name is. So what we can do is we can send email from marketing at the company name to the different people in the company, with the text that says new screensaver for company, whatever the company name is, click here, okay? Now, you all get a whole lot of junk mail, email messages, right? I'm sure every one of you get like 20 or 30 kind of junk mail a day, and you just delete it right there, okay? But I ask you this, if you see email coming in from marketing at your company, and the title of that email contains your company name in there, perfectly spelled okay, then the chances are a little bit bigger that you will have a look at it. Maybe not execute it, not the crowd in here, but the people that's working in your sales department, working at your marketing department, even the directors of your company, they won't be able to really distinguish that from just normal junk mail, right? The one thing that we also do is in the URL that we're sending, we're putting in the, let's say, intranet.companyxyz.com, and after that we put a little @ sign, right? And after that we put the URL in hex encoded format, so that it looks like the link that the person is clicking on is really sitting on the internal network, and there's possibly a few people, these people here, I'm sure you know, that the part before the @ is then treated as a username, right? And you've all seen that. But normally, you know, this will get past most of the systems. When I was typing up the slide, I saw that, you know, even PowerPoint think that it's valid because it put a little line under it. Okay, so even if I say all of this, you probably won't believe me. So we did some testing. We contact a client of ours and asked them if we can do a little test on their company and see if we can mail the people in the company. At the end, they agreed that we can mail the security team of the bank, and those were 13 people. So we did exactly this kind of thing, and we mailed 13 people. Now, because the web server where they're pulling it is under our control, we can exactly see who was actually downloading the particular exe. It was a straight exe. And the content, the payload of this thing, we obviously didn't make our super worm. We made the payload of this thing a little modification of the Trojan that we spoke about last year, that will open up an invisible browser and connect to our web server. And it would then only extract the username from the person that's running the thing, and it will report it to us. So we know exactly who downloaded it, and we also know who executed it. Okay, so here's the stats. 13 people in a bank. 8 of them downloaded it. Okay? Now when you download this thing, your browser really goes ape. Okay, it says, you're about to download something from a site where the CA, where the certificate on the machine was not signed by a known CA. Okay, that's the first thing. You're probably not going to have this on a site with the name that you got from VeriSign, with the certificate that you got off VeriSign, right? So the first thing we have there is that it's complaining about the certificate. The user goes, hey, you know, it's my intranet. They probably have self-signed certs. Let's just go on. It then says you're about to download an executable. User says, that's cool. And it then says, you're running this thing, and I don't know if it's, you know, you really want to do it. Well, you know, 5 of them executed it. And the thing that we sent them, the little exe that we sent them, did nothing. We couldn't see any screensaver popping up or any of this. So the one guy, like, clicked on it 3 times to see if it's, you know, let's get this thing working. So really what you find is that even if you think it's not a good way of doing it, it's actually a great way of doing it. The other thing that you need to, well, we'll get to that just now. Okay, so that's delivery. So now the next thing is, how do you find these email addresses when you mail people? Okay, so how do you find someone if you know they're working at a specific company? You Google for their email address, or you Google for the company name, right? And you Google for their name, and then you can find their email address. So Google is really your friend. And when you start searching on Google for plus at and the company name, minus www dot the company name, and you start scraping that, okay, you basically take the output of that and you start processing that. you will find a whole lot of people's email addresses. And these are typically people that ever post anything on the net, like in a guest book, or they write to a news group, or they write to a mailing list, or this kind of thing in that company. Their email address is sitting there. Their email address is sitting there on the internet, right? And you can scrape it. It's a little bit of a problem because Google doesn't like you scraping their web pages, but they've got this API as well. I know, but it's kind of not really there. So we're just scraping it, and we hope Google doesn't mind too much. So to give you an idea of how this works, I've really picked like a random domain, and this is something called Hariyet newspaper, which is a newspaper in Turkey. And you can see when we run this little Perl script on it, we can extract, a whole lot of, I think there's 83 different people, email addresses that we can scrape off Google. Now let's think about it. We got this thing that if we can execute it in an internal network, it's going to be really destructive, right? That's the idea. We have a company, we have a method by which we can extract email addresses once we have a company name. And we got this delivery method that says we're basically just going to mail someone an EXE. And we know that they're going to execute it. The interesting thing here is people whose email addresses are mentioned on the internet are probably people like your CEO or your salespeople or your marketing people or that kind of thing, right? So they are also the people that you want to target. So it kind of works out very nicely. Okay, so now we have these things, and we say we want to make this now relevant on a whole country. So how do we start footprinting a whole country in terms of the companies? Remember, we're not interested in getting the IP addresses. The whole focus has now shifted from the kind of normal cyber terrorism that we know about that says, let's find the IP addresses, we'll DOS them off the planet, or we'll try to hack in there. We don't want to do that at all. We simply want to find companies that are companies or organizations within a country. So the following sectors we're looking at, and these are the interesting sectors that if you take them down completely, you will find that the country will have some kind of impact. We look at, first of all, at telecommunications. We look at energy providers, that's your hydro, nuclear, fossil fuel, oil, those kind of companies. Government departments and the military. Media providers. Why do we want to go for media providers? The reason we're after media providers is, as you all know, the press kind of hype stuff up, right? You tell them a small little thing, they put it on the front page of the Sunday Times. And the reason why we want to target the media is that they can make an event like this much bigger, and they can create the kind of hysteria that we want, even if it's not that effective. We're looking at financial services. We're also looking at prominent businesses. Why do we look at prominent businesses? In some countries, you will find that, let's say, 70% or 60% or 80% of the country's GDP is coming from one big oil company, right? So we want to target those companies as well. We're looking at emergency services, and we're also looking at transport. So how do we do it? Well, it's more difficult than you expect it to be, okay? With limited time. Let's look at, we're going to split it into two parts. We're going to look at private sector and public sector. Okay, in the private sector, your problem is this, right? You want to find all the companies, and you want to do it automatically, right? Because you don't want to sit there editing a database. The problem with online directories, such as Google or DMOZ, is that it's not that specific. You think that it works very well, but it actually doesn't work that well. And the solution here is really to look for specialized kind of directories. So if you're looking for telecom, if you search around a bit, you will find a directory that lists per country all the big telecommunications providers within that big country. Some of them you can't just have one little flat page with all of the companies and the domain names on it. because you have to click here, select the country, go there, and at the end of the day you get it. For that kind of thing, we can emulate a browser quite easily so that it would do that for us, right? So we have to extract that stuff online. Some of the other stuff we can put in a database and have it on our server, and it's static data. Now, if it's static data, you have the problem that if something changed, let's say a new telecommunications provider you find it in the country, then we've extracted it so we can't get it live back, right? In some cases, it's better to have it locally than to extract it online. To extract it online, sometimes the server is down. You now have one kind of single point of failure, and that's that particular directory. Some guys don't like you to scrape all their information, and so they blacklist you. So it's kind of a trade-off between the two. The bottom line is, if you have enough time, you can construct such a directory quite easily. We didn't have a lot of time, so we kind of did it online as well. When you look at predominant businesses, you look at big businesses in a country, the problem that you find there is there's a couple of guides that will give you very nice statistics on the top, let's say the top 10 or the top 100 companies within a certain country. The problem here is you have the name of the company, and what you're really looking after is the domain, right? They don't give you the domain. So now you've got to find the domain. So we devised this little plan to actually have a script that you can put in any company name. And once you put in the company name and the country where that company is operating in, it will find out what the actual domain name is. It's not as easy as it seems. In the paper, page 9, don't go there now, you will find that there's an algorithm for actually doing something like this, and it's all on scoring and that. And we don't always get it right, so sometimes it's wrong, but most of the time we get it right. When we do the online demo, I will show you sometimes we get it wrong, and then we give you different choices of what domain to actually take. In the private and public sector, in the public sector, we're looking at government and military, right? And this is where it gets kind of interesting. I want to introduce the concept of what I call a sub-TLD, which is a top-level domain, but it's not really the top-level domain of the country. It's one hop, away from there. Now, you would think that just about every country you have the government is .gov, whatever the TLD is. Not right, okay? You don't have that with every country. For instance, France is gouv.fr and not gov. And so there's a couple of these countries that doesn't have just .gov.fr. And what we want to do there is we want to start looking at different government departments or different sections of the military, right? And there's a way that we can do that. We have the Google scraper, correct? We have the thing that if we put in a domain, we can actually get the email addresses coming back to us. So let's say we scrape gov.za. Once we scrape gov.za, we find that there's a whole lot of subdomains within all of the email addresses that we scrape. Okay? So now we can take these subdomains, pipe it back into our scraper, and find all the different parts of the domains. If you look at the US military, for instance, it's crazy. You find email addresses with 4 or 5 or 6 different pieces, subdomains, before it gets to .ml. And if we do this recursively, we can get all of these different departments, given that people actually send email with the email address that was contained in any of those subdomains. Okay. What we also find is that many of the military domains in certain countries don't have a specific .ml or a .mil or something like this, but they're basically contained as a subdomain within the .gov domain. Okay, good example of this is I think Germany. Germany don't have a .gov. They don't have a .mil. They do have a .gov, and their military is contained within a certain portion of the .gov. And like I said, with recursive scraping, we can find all the subdomains for a particular military or government kind of organization. we've actually decided to build a GUI for this, okay? Because Keith asked us to. Okay, you don't need a GUI for this, but we thought, you know, it's kind of nice to have a GUI for this. So what I'm going to do is I'm going to put this this little wireless card in here and hope that it detects it nice and everything is cool. It seems to be, and I'm going to show you what it actually looks like. You don't need the GUI really. The GUI is just nice to see, and it gives you some idea of what we've been playing with. Okay, so when we start off with this kind of thing, we get a little map, a sun map of the world. Why do we want to have a sun map of the world? Simply because a lot of this stuff is built around people reading the email, right? And you don't want to start an attack on a certain country if there's no sun shining there, because then people are typically asleep. So you want to know who's awake at the time so that you can send the email to someone that's awake. And so we built this little sun map, and the sun map is kind of current as well. So I'm going to go and select a continent. So let's go for North America, for instance. And we get a little map there. See, nice GUI. And let's, you know, select the United States. Why not? I mean, we're here. So I just want to tell you the thing is not running live. Okay. Okay. I'm going to click there on United States. Once I get to United States, I can select the kind of industry that I'm interested in. So because we have so many military and government people here, I'm going to select military and government. Okay, now basically what it's doing now, it's basically going through the whole Google thing. It's scraping Google. It's trying to work out all the subdomains, and it takes a while to do that. It shouldn't take too long, I suspect. Okay, there we go. Okay, this was now online, so it's, you know, this is not coming from a database. It's kind of live. So in government, you can see that it's found a couple of subdomains within the government network, which is I don't even know who these people are. I guess DOE is Department of Energy. I don't know. Okay, so we can scroll down here and we can find all the different .govs. We also have the embassies in there just for fun, you know, the American embassies in some of the other different countries. We scroll all the way down here. And we got the military as well. The embassy stuff was actually coded in there 30 minutes ago, so this is the first time I see the embassies as well, so it's quite cool. So let's see how good the actual email extraction program would work. I'm gonna like click on that one there. It's not live, guys. It's not live, okay. And I'm gonna say let's extract the email addresses of that domain over there. So now it's busy basically scraping Google for anything that's got pentagon.ml at the end, MIL at the end. And we find you know, a couple of people working there. Okay. So these are people working, I guess, working at the Pentagon, and we can mail them all. Well, I'm not going to do that though. Okay, so you can see how it works. It's quite nifty how it all sits together. Now, what we have here is that per default, these addresses are not selected, right? And when we go one back, these different military and government, I'm getting nervous here. Okay. that they are not selected, right? But obviously, in real operations, this thing would be, all of them would be selected. And so it will extract the email addresses of all of the different departments and embassies and that kind of thing. Let's just not go here right now. So if you go to Africa, for instance, and we click on South Africa. So if I go through the whole thing and I say energy providers, newspapers, prominent businesses, government, military, financial, and transport, let's just have a look and see what it comes back with. Now the energy providers and the telecom providers we have coded in a database, so it's not doing that in real time. So immediately you see all the different energy providers, you see the telecom providers. The newspapers are extracted online as well off a site. Prominent businesses. The SensePost in there is hard coded, and it's hard coded for a reason. Okay, because I want to demo you how the email sending would actually work. You can see we also have a whole lot of different government departments. The other thing is, when it finds in government and military something that sounds interesting, it would make it red so that you can see it quite clearly. And we got the embassies. Our military does never, they don't do email, so you must realize that it only works if that particular domain is sending out, if there's people sending out email. That's the only way that we can get the subdomains, and it's also the only way that we can extract the email addresses. Okay, we got the financial services, and we got airlines, and we got railways as well. Okay, and you will find that with some ones they can't extract the domain because the domain is just a company. They don't have an internet presence at all. All right, so we coded in here SensePost as a predominant business. It's not, but just to give you an idea of how it works. So I'm going to go to there and hit email, and it will extract the email addresses of people working at SensePost that's posting stuff. You can see the stuff is a little bit buggy as well. Okay, so that's me. Harun is there at the back, and Charles is right there. So I'm going to select myself there and send email to myself. Now basically what it's doing now, it's really constructing that email message that we talked about. New screensaver from this and this and this. It works out the MX record, the correct MX work record to send it to, and it's now sent me that mail. When I checked 2 hours ago, the power was down in South Africa in my little, in the city that we live, so I can't show you the email itself. We'll check just now and see if that email has arrived, and then you can see what that email looks like, and you can understand that your sales department, they are all going to click on it. Okay. The other thing that we've done as an afterthought, and it's really just as a kind of an afterthought, we have built in also the ability to do a little bit of basic kind of footprinting. Let's say you are interested in breaking in there over the internet, then you want to know what the IP addresses are and that kind of thing. So I'm going to go to South America, and I'm going to go down Venezuela, and I'm going to look at telecom providers. And there's a company called Digital, and I'm going to click now not on email, but I'm going to click on footprint. Okay. So basically what it's doing now, if you were at the Black Hat Seattle and the Black Hat Singapore, we did a talk on doing some footprinting. There's a whole lot of that technology now built into this, just to basically get a footprint of that company. So immediately you see that it well, not immediately, but it kind of quickly does a kind of a basic footprint on that company in order to give you the IP addresses. What's nice about this is if you have the IP address, you can now go and click on one of them, and you go out to Geek Tools, and if you look, you can see that it is belonging to that company. Plus, you can get exactly the range that that company has operated in. So if you want to go and try to hack in there anyhow, you've got the IP addresses right there. It goes a little bit further than that, because there's a little thing that says scan these. Oh shit, did I click on it? No, I swear, I didn't want to click on it. I only wanted to show you where it is. It's okay. I swear. No, I promise you. Yeah. Okay, but it's cool. We stopped it. So it will then go and do some mandatory kind of scans on those IP addresses to find out if there's any kind of low-hanging fruit vulnerabilities on those IP addresses that could maybe be used to gain entry. The idea there again is that you can't go for a very complex hack on a large number of machines at the same time. So the idea is really to find the stuff that's hanging there, checks for WebDAV, double-D code, Unicode, that sort of thing, which is terribly not exciting, but it's something that you might want to do. So it goes a little bit further, this little thing, and then there's also a kind of exploitation module in there, but you can appreciate that I can't show you this live. Okay, so let's just go back to there's another feature that we just pulled in here. That if you click on the name of the country, it will go to the CIA World Factbook and just give you some indication of the economy of that country, so that you can make a kind of decision on what kind of companies you would like to attack in there. And that's Taiwan. I told you it was a little bit buggy still. Okay. So in conclusion, what are we saying here? We're saying this is a kind of a framework that could possibly be used as cyber attacks. I'm very cautious to call it cyber terrorism, because we've never seen something like this happening, and we don't know what the impact would be. For one thing, I'm kind of sure that it would have a negative impact on the company and on the country if you're doing it at the same time. How does it compare to real-life attacks? Well, I think real-life attacks are much more horrifying, and it is a horrifying thing. These kind of the things, it's very difficult to predict what the impact would be and how far this biological agent would infiltrate into the network, and if it will ever jump onto control systems and that kind of thing. We don't know, and it's difficult to provide you with statistics on that, other than doing it, which we're not going to do. One of the things that's important here to realize is that this is not difficult, right? I mean, have you seen any kind of O-Day technology in here? No, it's not difficult to realize. It's a whole lot of different components that are quite easy and understandable and easy to put together. And though when we look at it, we kind of go, whoa, So what I'm saying is the chances of this happening and the chances of this being developed by someone, I think is rather large. I think where something like this could have a real impact is when it is combined with kind of physical attacks, because then the networks are down, and then you really have a bad situation. Should we really worry about this? There's a whole lot of people that says, cyber terrorism is not a big deal. The more networks are becoming connected, and the more we are putting critical systems on networks that are ultimately somehow connected to the internet, the bigger the risk is that such critical systems is going to be compromised by what I call a kind of biological agent that is sitting somewhere in there. We've also seen in here that breaching the perimeter and running code on the inside of a network, any kind of code that you wish, is not difficult. You needn't break into the network. You needn't have to breach the perimeter. You can basically get code running on a whole lot of different departments and a whole lot of different companies exactly at the same time by simply mailing people an executable that they have to pull down. I thank you for your time. Any questions? No questions? Are you kidding me? No. The site that it's running on is protected by passwords as well, and the actual module that we're using for the actual thing that it mails out is harmless. So no, we're not going to make it available at all. But you can imagine that building something like this yourself. Kijk, the thing is, the core of this thing is basically that the bullet of this whole gun is sitting in the thing that you mail out, right? This stuff is simply doing the positioning of your targeting. It's simply finding the correct targets. The bullet itself is sitting in that exe. And to tell you the truth, we haven't developed that exe. That worm that I'm talking about, it's not, it doesn't exist. But to build it, you can appreciate that to build it is not that terribly difficult to put it all together. We know about all these exploits. We know exactly how they work. We know how they sit together. Anyone can build it with a little bit of skill. So yeah, it's a little bit theoretical as well, but I think building something like that is no big deal. Yeah. What we can do is we can quickly look and see if that email has gone back to me. I don't know if our network is up and running. So we can quickly go and see and have a look and see. Okay. Okay. Where's the address bar? I took it out because I don't want everyone to see the URL, right? You can probably get it if you really want to. It's not a big deal. Let's just quickly see if that mail is there if you're interested. No, that doesn't seem to be up. Just want to check something. We most of the South African ISPs still communicate with 300 baud acoustic couplers, so you know. No, it seems to be done. But basically what it says is, it looks like an email really that says it's coming from marketing@sensepost.com. It says new SensePost screensaver, click here to download. It's got a thing that says https://intranet.sensepost.com and then in hex encoded is the URL of the correct exe. Okay. Thank you guys. Thanks for being here.